Okay, my name is Wayne Gramlich, and I am the president of the Brew Robotics Club this year. It was last year and the year before and the year before that too. But so, I'm going to tell you the lay of the land. First thing, how many of you managed to get in here without a badge? That's too many. Okay. I'm going to bring the badge box in here, and as long as you're in here, nobody will hassle you. But if you need to go to the bathroom, you need to have a badge. Where is it? I put it out in the lobby. Yeah, sure. Okay. So speaking of bathrooms, the bathroom is down the hallway. You sort of zig out, and when you see the elevator, turn right, and that's the bathrooms. We are only allowed in this building between here and the bathrooms and leaving, okay? They don't want to see us on the second floor. They don't want to see us wandering around the building. If that happens, we will get in trouble, and, you know, bad things could happen. Okay. Let's see. Usually what we do for the agenda is we do club-related stuff first. And I wanted to introduce our secretary-treasurer, but he just walked off to get the badges. Then we do other robot-related stuff. And so, let's see, Maker Faire happened earlier in May, right? So we don't have to do a Maker Faire thing again. Anything else robot-related? Yes, Ed.
I'm pleased to say that July 20th at SRI in Menlo Park, the IEEE Robotics and Automation Society, the technical talk and the topic will be robotic missions to NASA's robotic missions to the moon.
Very good.
And I'll put more details on there.
Thank you very much. Okay. I will explain membership and dues. How many people is this their first time here? Okay. So the way this works is we are a club, and membership is $10 for individuals and $10 for families. We've decided to be family friendly. Okay. If you have come to several meetings, we'd like it if you would join. Okay. Make sure you're going to be a regular before you join. We're not really asking people to sign up immediately. Okay. And our secretary-treasurer is holding the badge box right now. And if you would like to join, or some people have been trying to join and haven't been able to find us, but he's missed a meeting or two. Sorry. And if you want to join, see him. He prefers PayPal. Okay.
Who needs a badge? Who does not have a badge?
If you don't have a badge, you know, we need to get you badged up. So that's the deal on administrivia. And normally we have show and tell, followed by a talk, followed by just people talking with another. And then pretty sharply at 10 o'clock, I kick everybody out so that the guards can go on to their next task. So that's the overall schedule. However, tonight we don't have a talk. We have an extended show and tell. And I let Camp Peavy run the meeting.
These 5 years, only 7 teams have passed level 1, with 5 teams passing actually this year. And now, together with 2 other teams that have pre-qualified, we need to go back in September, back to Massachusetts and around New Park and find 10 samples and win the rest of the money, which is somewhere between 250,000 to 1.3 million, depending on how many samples we find.
You can't kick them in like this out there, huh?
Yeah. So this year in level 1, they actually made it much more easy to do the runs, so they actually gave the teams continuous blocks of time, 1 hour at a time, and teams could do anything they want on the field. That hour just needed to contain one successful run, which brings back 2 samples. And some teams spent many hours on the field, like 17, 18 hours getting their stuff to work. We used 2 attempts, so
hour and a half.
yeah. So Greg, you are back, so you can.
I'm back. All right, sorry about that. So you saw us run the demo, which is pretty much what we did at Worcester, what is it, 2 weeks ago, 3 weeks ago. And one of the things you got to kind of remember is that we packed this thing in a suitcase. We actually took it apart. I shipped the batteries and some motors a week before. And on Sunday, we were testing out a football field. At 1 o'clock, Kurt says, I can make it go fast. And I go, no, let's not. Let's just do it. It kind of did what we wanted to do. So we then took it home, disassembled it, put it in 4 suitcases, flew with it. The next morning, we were at Worcester, and we had it running at about 1 o'clock. If you look at anyone else's robots, they ship them all as is. They're so fragile that they have to basically go into one box as is and stay that way if something wires break or anything like this. This is very modular and very useful. In fact, we're now in the process of making a second one, so we can hopefully try 2 robots, so we can do things on each of them, different casters, different encoders. But what's really interesting is I don't have a laptop here, but if you go to, NASA Challange and look under sample robot return, you can see the Worcester's website where they kind of give you all the details of the next event. And the next event is over Labor Day. There's 7 teams that are going to that have qualified to do this, and they're going to basically tell us where we can go search within a kind of a 10-meter area. So there's 15 spots that we have to go visit and see if there's a sample. If there is, pick it up and take it back. And we have, the challenge of being 130 to 140 meters away from the home plate, so our camera system has to readjust because it's really only good for about 50 to 60 meters. So how are we going to see how that, so that's kind of the work we've got for the next run, but we also have never run the robot for 2 hours, so hopefully it's got enough battery and power to run for 2 hours. There's all sorts of little challenges. This is definitely a team effort. Bill has been instrumental with the mechanical side of it. I've got Alan, who's made a base for us. I've got David, who's making RF radio direction finder. Hopefully we'll have it working. Manu here, who's put together some stuff that does the displays. Gertz has done 100% of the software. I haven't had to touch any of it. I'm more the arts and craft guy. He kind of asks for something, and he goes, oh, it'd be nice to have this, and I kind of scratch my head. Okay, we'll see what we can do. And so hopefully, there's really not much change that we're going to do to this robot. It's going to pretty much run as is. We've got to come up with a couple fine-tune adjustments for how the gripper works on real grass. We have it tuned for AstroTurf because that's where the level 1 test was run. So now with deeper grass, we got to figure out how to not get caught in the grass and be able to close things. And then we're also talking about having, if we're really lucky, we can pick up 9 samples. There's a maximum of 10 samples out in the field. Pick up all 10, we have to now land them on the platform correctly without them touching, or else they would get disqualified, so we get to work on that problem. So all in all, I think we're very comfortable being a very good competitor just with picking up the samples we can see from the starting platform. And then if we're able to branch out and go further into the park, we could really be very successful. So, any questions?
How confident?
How confident?
Yeah.
Well, my hubris says that we're going to win it all. I believe, we have, we are one of 2 competitors who can actually do the challenge. In doing the risk analysis, there are several robots that carry the samples with them.
instead of dropping them off one at a time. So you have a fairly higher risk. You can do the field faster because you don't have to go back to the platform, but you have a higher risk that you have to have time to be back on the platform for everything to count. So it's an all or nothing type proposition. So there's really only 2 robots in our class that basically drop samples off. There's a third one in Alabama who just showed up that might be competitive. They're kind of sloppy in the way they do things, so I'm not sure. But they also carry everything with them. So Voyager and ourselves are dropping off samples. So as we just run, we collect points. So at no point in time are we at really risk of the robot stopping or getting caught, not getting points. So that gives us fairly good confidence. Yes?
Yeah, so it sounds like there's some serious prize money on the line here. What are the various payout levels?
The first payoff level is you have to get so many points. I think it's 4 to 7 points, and that's 250,000. And then from 7 to 13 points, it's like 700,000. And then 13 plus, it's the full payout of $1.3 million.
What earned you points?
The samples, what you pick up. If you saw the metal samples, those are called hard samples. They're worth 5 points. There's 3 of those on the field. There's the purple rock. There are 3 of those. They're 1 point. There are other smaller rocks that are can be any color, basically. I've got a garage full of painted rocks. I've got little yellow rocks and little pink rocks, that we're going to try to pick up. And those are worth 2 points. So that's, your ability to go pick it up. You also have to pick up the pre-cache, that's 1 point. So within visible sight of the platform are 5 sample areas. There's a total of 15 sample areas in the whole park, and there's basically 9 samples. Not count the pre-cache because it's in its own little area. So, you can imagine there's probably 3 samples within the visible area plus the pre-cache. So, a low, a high, and a medium. There's 8 points right there plus the pre-cache. You could actually, do it without having to go outside of the area. But again, you have to be really confident. So, there's game planning and theory. If we go to one of these far areas, do we just find a sample and come back, or do we check all the other samples areas and knock them off and say there's sample there and not sample? So our confidence level that we've explored an area has to be really high. Yes, way in the back.
So when you win this 1.3 million, how is that going to be distributed amongst the club members?
Good question, Ryan.
That's a good question. I don't know. I never talk about commissions or anything until the checks clear the bank. So, yeah. So, all right. Anybody else?
Greg Maxwell, team maxed out. Some of the best advice I ever got from Ted Larson, who says, if your robot does what it's supposed to do in the backyard, it'll do it in the contest. To which the counterpart is, don't expect your robot to do stuff in the contest that it didn't do in the backyard. Anyways, we actually have 2 NASA SRRC robots, Sample Return Robot Challenge. There's Max, Team Maxed Out, and there's Beast back there from Team ARG, ladies and gentlemen. That's a NITO-sponsored robot. Yes, you can applaud. So before we get moving here, Chris Myers wants to make an announcement regarding the HBRC junk box, and I find high-quality robotic junk. That's what we call that.
It's not junk.
Sorry.
It's cool robotic stuff. I started this box to get incentive for people to come and bring and show your robots. So the rule is simple. You bring a robot, you show it, you get a free thing from the box. There's cool things in here. Microcontrollers.
It's affectionately known as junk.
Junk.
Other people's
Good junk.
J-U-N-Q-U-E.
There's toys, solar cars, there's Arduinos, there's audio shields, there's all kinds of cool stuff. Beagle bones. It's kind of an honor system. This will be in the back, so when you show a robot, just plow through and grab something.
And the deal is you need to bring it back within 12 months for show and tell, something robotic.
Yeah, sort of. Mostly so.
More the guideline.
Bring your robot and get more robot parts to make your robot better.
Okay. 14 years ago, a group of us at the SIG, the Special Interest Group, were lamenting the lack of building progress in the club. We observed that building coincided with contests, but contests always had these stages and things that had to be set up and stored and so on and so forth. At the time, we met at Castro Middle School, and we were brainstorming on what to do, and we wanted to do tabletop soccer, and the spirit of Bill Benson was there, and we kept hearing the words non-trivial, non-trivial. And so we're like, okay, well, we could put these robots on the table. We could put nets around the table. If the robot fell off, it catch. No, that's setup. We knew that we had dozens of robots in the club, but, you know, nobody was bringing them. Nobody was doing anything with them. And so that's when it was born, the TableBot. A TableBot is a robot that can survive, live, and play on a table. Now, how do you get to this level is you do it one step at a time. So we started doing it in phases, starting with the June meeting. June was defined as phase 1, where the robot was just to go to one end of the table to the other and back. Phase 2 was push a block off the edge of the table, and phase 3 is move the block into a shoebox mounted at the end of the table. Now, since then, we've come up with the unspoken phase 4, which is it's okay for the robot to fall off the table. It just still needs to function when you put it back on. So without any further ado, I'm going to have Danny Watson run the TableBot Challenge. Thank you very much.
Hello. So anybody here have? Okay, I can do this. Hello. Yeah. Hello. Does anybody have a robot that they think can go from one side of the table to the other and back again? Camp?
I do.
Camp does.
I'll actually do stage 2. We'll put the block on the table randomly. Incidentally, we do not define the size of the table, the size of the block. Hello.
Battery's dead.
You can bring your own table. You can bring your own block. You can color it.
It has to. That has to do with no setup.
You can tie it in a knot. You can tie it in a bow.
And you throw it over your shoulder like a continental soldier.
That's right.
If your ears hang low. Oh.
Hey, someone
Hey.
else knows that. All right.
Right in the way of TV.
Missed it by that much.
Oh, so close. I'll be here a while. Oh, there. Oh, no. Is the camera zoomed in on? Camera's on me.
For the record, that's phase 1.
Phase 1, everybody. Yeah. We did it.
One and a 2.
Phase 2 is to, I think, push the block off the edge of the table.
Peter.
I don't know. It's
We're
probably
not
gonna do
proud.
it. It got hung up on a little piece of tape on here. Take that off. Okay. Does anybody else? Let's have a round of applause for Camp.
And Club Bug.
And what is the name of the robot?
Club Bug.
Club Bug. All right. So that's a fairly simple robot. Anybody else who has a robot that thinks that they could make it go from one end of the table to the other end? Paula? Oh, we have somebody else coming up.
One over here.
You can go first. You sure? Yeah.
Just so you know, the first part is the TableBot Challenge. Next we'll do the FloorBot Challenge. Then we're going to do Ralph's Amazing Line Maze. Then we're going to have the Robot Dance Party. And the last part is Run What You Brung for all the robots that don't fit into any of the specific categories. Go ahead, Danny.
We're showing Challanges for not functional robot.
Yeah, that's Run What You Brung.
Say your name.
Don't run what
If anybody understands, we do.
Okay, my name's Mark, and this is my robot. It's a Fear No Robot Mark II using the trademark ABR Camp PV Always Building Robots method. A little bit about it. So right now it's just a jumble of wires, as you can see. This is the prototype phase, just to get it going. It's got some IR emitter sensors here on the front that it's going to use. It's using a Tiny Circuits Arduino controller with a motor controller. And a lot of this other stuff here is just some power things. The goal of the robot for the challenge is to eventually, it's going to be a very versatile robot. It's actually going to try and compete in all of them. Today it's only TableBot. but I want to do the amazing challenge and. Oh no, yeah, that's okay. Yeah, that was not supposed to be connected. But that is the goal. It's going to do the line following. It's going to do the object avoidance here, and we'll see. But
what's your robot's name?
Fear No Robot Mark II. Not after me, but you know. All right. So it had some power challenges earlier today. So we'll see. The strategy it's using right now, it actually has some motor encoders, so it's going to drive fairly straight to the edge of the table. Then it's going to rotate, turn, find that edge of the table, and then come back to this one, hopefully, and not fall off.
Drum roll.
Where's your tape?
Oh my God.
Where's your tape?
Here, I'll do it again.
That's very fast.
Smooth.
Oh, well, no, now it's confused. Yeah,
What kind of wheels does it have?
I'm using some Pololu gear motor ones, which have worked out pretty well. Actually, when I was testing this out, I had to slow it down. The high speed on this, it will easily go faster than the sensors can send the data into, like you're about to fall off the table. So yeah, trial and error. A lot of these are 3D. I 3D printed all of these parts here. And then I did a little custom PCB for these for the time of flight sensors, which aren't hooked up yet, but will be. And then the goal, like I said, is to turn this jumble of wires into a more, I don't know, yeah, like another custom PCB. So we'll see. We'll see it evolve over the challenge, hopefully.
Show me your robot, Mark.
Smile.
That's good.
All right, that was Mark, I think. Yeah, Mark. Yes. Mark. Oh yeah, Mark II. But okay. Now, is there anybody else who can do the tabletop challenge? Come on up. This is Pollock. Do you want to take this and say your name and explain?
Hi, my name is Pollock. I am a simple engineer. I aspire to be as good as these robots, but this is a robot I did with the help of him.
What's your robot's name?
Sinister Smiles. I made this a year ago, so I had no sense of naming things. I would have named it like Happy Face Rainbow Thing. But that's my opinion. I don't know how well I can do this, but... And it's slow, so very.
You can do it the shorter distance if you want.
What?
No,
It's doing fine.
It's fine.
It increases the tension.
I have faith.
All right, look at
I
that.
trust my robot. I trust that it will
Yeah, I
not
trusted
kill
my
me
robot
someday,
Phase 4.
so. Yes. Oh well.
Trust but verify.
Yeah. Trust but verify. So let's do the short distance. That way.
Oh yeah, that way.
Yeah, that way.
It's going to die. One of the things I did with this earlier, I just didn't have the program running, is I put like a paper down, and it was able to write the first letter of my name, which is the letter B, and I had attached a pen here with a screwdriver that was unnecessarily duct taped really hard. That was the weirdest thing I ever did.
All right.
Thank you. So that's Pollock. I know her because I helped her build that robot. I teach a class where I teach people to make their first robot, like that. Yes, I am promoting myself. Is there anybody else who wants to do this? Yes? Yeah, come on up.
Mark Johnson.
Sorry about the laser there. Hope I didn't take anybody's out.
Is that the fiddler bot?
That's where the laser. I saw it.
It has been repurposed because I've been putting off trying to do this challenge for a couple years now.
Is that a new claw on the fiddler
Yeah, it's
rod?
not a claw
So I think
anymore.
this is going to do
Let me see
phase
that. Show me your robot,
2.
Mark.
Yeah.
No, maybe phase 3.
Yeah, this is hopefully going to be all 3 with some AR tags and some
All
cool
right.
stuff.
Act like you're having a good time.
I'm having a good time.
So phase 3 is, remind me of what
Oh,
phase
it just
3
said
is.
it right
Picking
there.
it up and bringing it back.
You got 3 phases. Phase 1, go from one end of the table to the other and back.
This is
Phase
a really,
2,
really
move a
long
block
table.
off the edge of the table. Phase 3 is to move a block into a shoebox mounted at the end of the table.
So
Where's your shoebox?
that cardboard
So
one.
I wasn't real clear on exactly what that meant. So
There's 3 instructions.
So this is not going to do the challenge, but it's going to do something kind of like the
That's
challenge.
okay. It
So
looks like a
it's got
shoebox.
these little tags that you saw like out on the big bot out in the back. These are AR tags. Yeah, it's going to go back and forth with, most likely it'll make back and forth on the table okay. And then it's going to find this tag here, try to approach it. Now, because I wanted this demo not to take forever, I'm going to make it do its best shot at finding it with optical recognition and then turning towards it and then going to it. It's a long table, so if my accuracy's off a little bit, I didn't take the time to get close to it and reposition and then really nail it. And that would be next time. This is a little this is a little target that allows it to get that object. Once it finds that, it's going to have a whole list of instructions to do. So when it gets to the edge of the table, it's going to download that list of instructions to itself, and it's going to try to find that object, and then it's going to try to find this object by turning and pushing the object into it. So we'll see how this goes.
Wow.
Okay, so here we go. So it's all supposedly set up at this point, and the RF control is going to only do one thing really. It's going to just tell it to kind of get started. I'm going to have to yell because I need my hands. So. All right, so this is running ROS operating system. It's been here before doing some other strange things and stuff. Now it's going to try to do something more on the lines of what the challenge is all about. So it's got wheel encoders and so forth, and it's got some odometry. That's interesting. I'm seeing a little bit of a drift. So we'll see how well it does at doing one shot at trying to pick up the targets on the way out. Huh, that's weird. They're identical encoders and everything, so it's a little bit strange. But on this side of the table, it'll turn around, come back. I think with the way it's doing it right now, it's probably going to end up hopefully over here somewhere. So I'll get this out of its way. And he's got a webcam. He's running OpenCV. That's what he's going to... Actually, he's not running OpenCV. He's running the AR tag recognition thing, which looks for these tags. He's going to turn around and try to find this. I forget which way I made him turn. If I made him turn this way, it might get exciting real soon right here. Ah, thank goodness. He's turning the other way. Yay! Now he's going to be looking around for this tag here, which is the number 2 tag. And he's going to scan around. When he gets over to here, it'll probably be in his vision. Uh-oh.
So
I did not turn on his headlights. That's a potential problem.
It just did phase 1. It went from one end of the table to
So
the
so
other.
now it's going to try to. I think it's seen it. It's showing up on here as founding it 50 centimeters away. So it's going to now turn towards it, and we're getting a little. This is the part where I'm not going to do a second reckoning.
Oh, nice.
But see the laser? You like the laser? I just lasered the thing, man. It is so dead. And this might make it. You see, it's just barely going to make it. Yay! Okay. So now he's done that. Now it's going to search around for that tag over there. That's the number 6 tag. And I'll be able to tell on the display here when it finds it. So far, no tags. Oh, that's not a good sign. This might be because of the table so long.
Move it closer. Move the tag closer.
I don't want to cheat, man.
Cheated.
All right.
It's not a contest. It's a show.
Challenge.
It is challenge.
No, dang it. It's not going to work. I think because I got the tilt too low on the webcam and he's not smart enough to actually go up any higher, and he's designed for a table that's this long right here. So
can you set it up differently?
It's not going to work now because what he's doing is he's going through his search algorithm and continuing rotating, not a good position.
Is
Because
there a way you can do it widthwise? Reset it up and do it widthwise?
Move it closer.
Well, the deal is they want to push it there. It's found tag 6 now, okay? But it found it. I lied a little bit. It's going to be actually turning over to there. So I'm Gertz's partner, by the way. If you saw the rocket back to that'd be funny. But so I had to smudge it a little bit. All right. So it's going to go up to here, stop there, and it's going to go about turn towards you there and take a bow, which it shouldn't because it didn't really do it. But it's close enough. Talking about is this thing had a little claw on it that I designed and stuff like that that could go up and grab something with a claw, lift it up and move it and drop it somewhere else. That was an earlier demo sometime back. So I put a different device on it and so forth. Kind of bummed it didn't do it this time, but I'm going to make it smarter next time, so it'll just basically be able to do a little more searching than it did this time.
Very nice.
But if you want to see it actually work, www.mark-toys.com. Go to the robotics page, halfway down, and you'll see what I did last night about 2:30 in the morning. Okay. So proof that it will work, given a happy environment. I'll come back and set that in a
Bring your
second.
own table next time.
Yeah, BYOT.
Yeah, you can bring your own table. Is there anybody else who wants to do the tabletop challenge? Any one of the phases? Oh, we got somebody else? Okay, come on up.
Mike.
What is your name and how does your robot work? What kind of controller does it have? There you go.
Come on.
So, hello everyone, my name is Mike. This is like my third week here. I haven't had a chance to meet everybody yet. I built this robot about 3 days ago. I didn't really think I was going to be able to compete. So, this is a Octobotics Sprout Run Rover powered by an Arduino. It's got a Seed Studio motor shield on top of it. And I have 2 ultrasonic sensors at the front for checking the edge of the table. Do I think it's going to go from one end and back? Probably not, but hopefully it stays on the table. It was really the goal I was hoping to achieve.
You can try it on the short way. You think that'll work?
Sure.
You can run it widthwise.
Okay. One end of the table.
One end of the table to the other. We never defined whether it was length or width.
End is a fuzzy term. Oh, that was fast.
You're awful relaxed there, Mike.
I ran this a lot yesterday.
All right. The table's got some curved ends there. Woo!
Never brag about your robot before the run is finished.
Still runs.
That ran around pretty quick too.
It still runs.
Phase four.
Robot demolition release.
Thank you.
It's worth the price of admission.
Okay. And, sorry, I did not mean for that to happen. Does anybody else have a robot thing that they want to try, the tabletop thing? Just unplug
Is
this.
Wireless a table bot?
Table bot.
All right.
He wasn't.
Very good. Nick's designing on the fly here.
Yeah. So this is Wireless. He used to.
What's your name?
My name's Nick, and it's first time here. This used to just be an obstacle avoidance robot. It would roam around my apartment. And last night I decided to try out and make it a table bot. And hopefully it will work. I don't know. Let's find out. Let's turn this on. So it just wanders around. I don't know if it'll get to the end of the table or not.
Width counts.
It's going to go back and try. There we go.
Gotta make it back.
So it goes a lot faster, but I have the power turned down quite a bit because I was nervous.
That's good.
So hopefully, all right, I don't have the encoders on, so this is actually going to help me. It's not going straight.
Cool.
All right.
Anybody else? Oh, we got another one. Oh, with a phone, it looks like. Or what is that? Tablet?
So this is,
So you're,
Oh my.
I'm Ralph.
Ralph Ganock.
Ralph North, Ralph 1 at the club. There's 3 Ralphs here now, so been a member for about 5-6 years. So this is a little robot that I built called Tango Bot. This is a Google Project Tango tablet. I'm not sure if any of you are familiar with that. It's a sort of Google research project that actually has 3D camera in it, and a whole bunch of advanced navigation, inertial and visual navigation. So my goal is to use those tablet features to do navigation. It's not quite there yet, but won't yet do the table bot, but hopefully it'll actually move. There you go. So it just has a little step forward function. So I mean, everything's 3D printed. It just has a little TI development board and a Polulu motor controller, but that's super dumb. You can put an Arduino. All it's doing is sending PWM to the motors from the tablets. All the smarts are in the tablet. So it's intending to use visual. I don't know if we can get a camera on the back onto the screen on that. Can we? Where's the camera?
There you go.
It's got, you can see some video going there, so it's using video. The tablet actually has a Jetson, the same processor, the NVIDIA TK1, so it has a CUDA GPU. So we're doing some OpenCV and CUDA image processing there. So the goal is to see the table and use the inertial navigation to be able to steer it around. And also using the visual, one day we might try to attempt the maze with it as well, but that's it for now.
cool. A lot of people tonight. I don't remember this many last
About
time.
60.
I mean, doing the challenge even.
A lot of table bots.
Yeah, a lot of
Need
table
more
bots.
table bots.
Any more table bots? Yeah. No? Maybe? Somebody? Okay then, I will talk a little bit about the thing that I do, and then I'll hand it off to, I guess, Camp again. Camp? Yeah?
Yes.
Okay, cool. So the thing that I do is I teach people how to make their first robot. So it's like a build your first robot kind of a robot. Polak showed hers, and I don't know if this is going to show up there or not, maybe? Is it over there? No? Okay. I have the power to turn off the screen. This one?
Is your laptop connected?
Yeah, it's connected. I did this last time I was here. I don't know.
It doesn't actually think you're connected.
Which is the, here it's the display board. This one. All right, I'll just talk about it. So yeah. Okay, so I do a robotics class where I teach you how to make your first robot. If you haven't done any, if you've never built a shelf before, and if you've never made your own hello world, or if you don't even know what that is, then you can come to one of the workshops that we do or the classes. And those are, you can see the details of that at challengebot.com. Oh, hey. So that is my secondary monitor. Let me see if I can bring this over there. That way? That way. It's that way. Okay, cool. So let's... So this is Bot Bunny and Computer Kate. They will help you build your robot. Some of the upcoming classes that we have, there's a summer camp, that's 5 days, but that's more for like 6th grade or so kids. And then there's the workshops, which are, the upcoming one is at the Hacker Dojo conference room, and you can go to the sign-up page for the summer camp. That's going to be at in Palo Alto, and then the workshop will be in the Hacker Dojo conference room. The Hacker Dojo recently moved. If you're familiar with its old location, don't go there. Make sure that you find the map here. It's still in Mountain View technically. It's like 10 minutes down 101. So you can email info@challangebot.com to find out more. And you can come talk to me during this class. I believe Pollock, when she was, her parents were here, they saw this class and then they signed up, and that's how they learned to build their first robot. And I will hand the microphone off to Camp now.
Floorbot Challenge.
Floorbot Challenge is
all right.
Moving right along.
Floorbot Challenge is next.
Yeah.